Welcome to the TEMA flooding and flash flooding course for swiftwater rescuers. I'm James LaRosa, the service hydrologist for the National Weather Service office in Nashville. Pictured here is a low water crossing common to parts of Tennessee and really elsewhere in the United States. This one happens to be in Rutherford County, and the pictures are from two different rain events showing that these low water crossings can be very hazardous. Some of the topics we'll cover today, brief introduction on weather and hydrology. We'll talk a little bit about winter weather, spring and summer thunderstorms, and the types of flooding that's associated with each of those seasons, plus look at some flood events from around the state and elsewhere. Here's a little bit about the atmosphere. This picture we see air moving from the northeast to the southwest over the Canary Islands off the coast of northwest Africa. As it does, the rising and sinking motion of the air creates eddies on the leeward side of the islands. And the fluidity of the air allows us to use fluid dynamics equations, which we will not cover, fortunately, to model the atmosphere. Vertically, you see that the atmosphere can be separated into 5 different layers. The troposphere down here at the bottom, this is where all of our weather occurs. All the way up to the exosphere here. You see the space shuttle. This is where astronauts orbit in the space station, which is about 250 miles above the Earth's surface. Weather balloons that we launch here routinely reach 100,000 feet, which is right here into the stratosphere. A little bit about the weather. The sun causes the Earth's surface to warm, and this warm air rises to form circulations. You see on the right side, the tropical air circulations are a lot taller than some of the polar regions. These circulations are higher there and then lower in the polar regions, and then when combined with the Earth's rotation, this constant rising and sinking motion forms 2 distinct jet streams which bring us our weather, the northerly polar jet and the southerly subtropical jet. The polar jet is more dominant in the winter, brings us those cold air outbreaks that we typically see in January and February, while the subtropical jet brings us our warmer weather. Those circulations aren't enough, and we need moisture. The bulk of our moisture comes from the Gulf of Mexico. The sun heats the water, evaporates it, turns it into water vapor, as we see down here. As the air continues to rise, that water vapor cools, forms clouds. And if the cloud continues to grow, the moisture will form larger and larger water droplets, and that eventually falls back to the ground where they run through rivers and streams and back into the oceans where they repeat the process all over again. In wintertime, that water vapor condenses into ice crystals that form snowflakes, and they can fall and remain until the snowpack melts. The weather models that we use show different weather elements like temperature, air pressure, dew point, and winds at different levels of the troposphere. We look at what is happening and then make a guess, although we prefer the term prediction, and what will happen at the surface that impacts you. The chart below shows a cold front across the Dakotas. That's right here. And along this cold front is probably shower and thunderstorm activities with colder air on the backside here and warmer air on the front side. Just to the north, here's a warm front that stretches into southern Manitoba and western Ontario. And along the warm front here is typically light to moderate shower activity. You see on these graphics here, here's the cold front. The cold front is moving this way, and that causes the warm and moist air on the front side to rise. In this case, with the warm front, you still get rising motion. It's just not as severe as it is with a cold front. And then over here in the Ohio River Valley, here's a stationary boundary that isn't moving, so cold air or warm air is not moving one way or the other. And there may or may not be any weather along this boundary until it begins to lift this way. It becomes a warm front, and if it were to push southward, it would be a cold front. If you look over here into West Texas, here is a dry line shown by this graphic here. To the east of this line, there is a abundant moisture from the Gulf of Mexico. We get an onshore flow like this. And then on the backside here in the desert is much drier air, of course. When you get a weather feature that tracks across the southwest and then finally taps into this moisture, you can see storm development occur right along or just east of this dry line. Let's talk about our winter weather. Winter typically rainy across the state with about 4 to 5 inches of rain falling each month from December to January. Winter rains can begin in November and persist into March depending on what the weather pattern is. Some of the bigger rain events in winter can bring a few inches of rain in some areas, but most places see significantly lesser amounts that do not lead to flooding issues. Where we see flooding develop is when we get multiple rain events and the water builds up into the larger rivers and streams. Two big floods on record, the December 26 into January 1927 flood and the January 37 flood into February 1937. Impacted mostly the western and middle portions of Tennessee. These were caused by repeated rains over the same area, just like we saw recently in February of 2019. The rain that caused the flooding in 1927 actually began in December of 1926. The stretch of heavy rain at the end of the month caused significant flooding along the Cumberland River, and not just in Nashville, all along the river. Above normal rainfall continued through the winter into the early spring, and this led to widespread flooding in the Ohio River and Mississippi River basins. And the Mississippi River at Memphis reached its third highest level on record that spring. The rain that caused the 1937 flood was similar in that it had a persistent above normal rainfall, especially in January, and the runoff just built up into the river system. In early February of 2019, a heavy rain event led to some flash flooding around Nashville. We see by these hydrographs here the quick rises and falls from some of the smaller tributaries. And while this was short-lived, the rain left the ground saturated with moisture so that any future rains, that runoff will flow directly into the rivers. And of course, in the second half of the month, did bring above normal rainfall, and that caused flooding on the larger rivers across the state. The bottom graphs here show what was being forecasted for the Cumberland River at Nashville and Clarksville. Almost 2 flood stage possible around Nashville, but looks like it was kind of forecast to be just below, but right into the minor flood category downstream in Clarksville. And that's shown in these orange shaded areas here. That's where the river is most likely to reach. But thanks to the Army Corps of Engineers, a major flooding was prevented on the rivers they control. And this event in 2019 was very similar to the rainfall amounts that we saw in December of 26. So you can see just how much the impacts are for these projects that the Army Corps of Engineers and TVA use to manage the flow of the larger rivers. And it's just interesting to see that not only are the amounts similar, but the placement and time frame in which they fell is also similar. You see in the western parts of the state, there's a maximum somewhere here around Jackson. And then kind of along I-40, we see the rainfall maximum, maybe a little less here in Williamson and Rutherford County, same thing in both events. And then higher amounts here on the Tennessee-Alabama border. As you head up into East Tennessee, you still see some rainfall, maybe not as much in the 1926 event, but the areas near Knoxville certainly saw a bunch of rain in February 2019. Despite the wet winter months, the highest flows on the Tennessee River in Knoxville and Chattanooga occur in the late winter to early spring. These top 5 crests shown, these are all pre-TVA control. So their controlling of the river plays a part, of course, but maybe snowmelt was more of an issue back in the late 1800s to early 1900s. We know it was definitely snowier back then. So even though winters are wet, they are not actually the wettest season for the west and middle parts of the state. Spring is. Not so much for Chattanooga and Knoxville. There is a definite difference in the winter and spring rainfall across the state. Spring flood potential is a balance between the higher rainfall amounts and more intense rainfall rates, and really how soon the vegetation greens up. A wet winter can leave soil saturated, and if the trees and bushes have not greened up, then less water is intercepted and more runs off into the creeks and streams. Thunderstorms become more intense during the spring because we have that interaction of cold air and warm air. Remember the cold fronts and warm fronts from the earlier slide. Southerly winds bring us moisture from the Gulf of Mexico. A higher sun angle gives us warmer temperatures, and an active weather pattern or jet stream brings us the three ingredients needed for thunderstorms, which is moisture, instability, and lift. Throw in a little wind shear, and that's a change in wind direction with height, and you can get strong rotating thunderstorms, and that'll be capable of producing high winds, large hail, and tornadoes. Any risk for flash flooding increases from these slow-moving storms or some type of environment where storms redevelop over the same area. Here in Tennessee, we seem to have a higher risk for flash flood deaths than heat-related deaths, which normally is the #1 weather-related killer. Some years, tornadoes are about as deadly as flooding, depending on how active the tornado season is and how often we get these tornado outbreaks. This is what we are looking at when we forecast the weather, and in this case, the risk for flash flooding. First off, you need moisture, and while unseasonably high moisture almost always leads to flash flooding, you can still get heavy rain from average amounts of moisture if the setup is just right. This upper left chart here shows the amount of precipitable water with the higher amounts in the orange colors. Precipitable water, that's the amount of water in the atmosphere that can be precipitated out. And then, of course, there's some isobars and wind barbs here, which show where a low-level boundary might be, and that's important. This one in the lower left is the height of the freezing level, and a higher freezing level is ideal. A lower freezing level will give you hail. And then in the upper right here, this panel depicts winds and pressure just above the surface, along with wind convergence in the intense colors right here. Wind convergence is important because that will indicate a strong upward motion and is often a location for the heaviest rain. The bottom right is moisture transport, and that's where the moisture is being transported up from the Gulf region here into the middle part of the state. And then this far right graphic is an example of the data the weather balloon collects. The red line here is temperature, the green line is the dew point, and the yellow barbs here are the wind speed and direction. When the red and green lines are closer together, like right down here, that air is really saturated, and that is really an ideal condition to produce heavy rain. The three radar images shown here each depict rainfall a few hours apart. And the total rainfall graphic here in the bottom left shows a area of 6 inches of rain that fell basically along the I-40 corridor from Jackson up through Nashville. And this event took a few hours to develop, over 6 hours. Other events occur more quickly, often within 1 to 3 hours. So when we are monitoring for the potential for flash flooding, it's important to look at different time frames. The May 2010 event was just like the previous event, but on a larger scale. It had a stalled boundary, it had plenty of moisture and strong moisture transport from the Gulf of Mexico and really down into the Caribbean and the tropics. The storms that developed produced rainfall rates of about a ½ inch to 1 inch per hour that persisted for 18 hours on Saturday, May 1st, and then again for 18 hours on Sunday, May 2nd. So this produced large swaths of 10 to 20 inch rainfall totals. And we see that stretch all the way from just north of Memphis through Jackson into the Nashville area in this graphic in the upper left. In the upper right here, this is looking upstream at the backside of Old Hickory Dam. You see all the water coming out of it. The bottom left here is a high water mark on Richland Creek in the Nashville area that shows the peak water level. And this picture is just above my head when I took it. And then, of course, you see some of the impacts from flooding. Anything not anchored to the ground, mobile homes, can be picked up and transported downstreams. And then on the right here, these people got caught. This is near Hendersonville. They got caught in the rapidly rising waters and had to be rescued. The Sumner County flash flood in May 2017 was this on a much smaller scale. We see downtown Nashville here and rain falling just right along this portion of Sumner County. It continues to fall here. And this chart in the upper right here, the blue line shows the instantaneous rainfall rate, and we see here's 3 inches an hour. The rainfall rate pushed about 3 inches an hour for 3 hours, and then the black line here shows you the total rainfall accumulation, which is about 6 inches in that 3-hour time frame. This picture here shows kind of the dangers of rapidly rising floodwaters. Kids on the school bus needed to be rescued when the driver got caught in the rapidly rising waters. I am told the driver was doing their route and came across a flooded portion and proceeded to back up and turn around. And during that time, the brief time to do that, water rose up and flooded the bus, so it became stranded. And that's where they called for help, and rescuers were able to get everybody out safely. For the western and middle portions of Tennessee, rainfall drops off a bit for the summer months as the jet stream lifts northward. Oddly enough, for East Tennessee, a notable increase in rainfall can be seen for the month of July. Not sure why this is the case, but there's a notable bump that is there for that month. Peak tropical activity occurs in the August and September months, so any summer thunderstorm activity you think would carry over into August that forms in July. Any storms that do develop across the state, these are generally slower moving, as the winds aloft to steer them are weaker than they are during the spring months. So we get these intense downpours that, since there isn't much to sustain storm redevelopment, the lifespan of a thunderstorm can be short-lived, which would limit your rainfall amounts. Here's a good example of the storm life cycle. Cumulus clouds develop due to the warm air rising, and if the updraft is strong enough, it can develop into a mature thunderstorm here, and eventually the updraft can no longer support the droplets in the cloud and it falls as precipitation. And that's where these intense downpours come from. Without that sustained updraft, the rain-cooled air falls, and that stabilizes the air at the surface, so storms do not redevelop, and eventually the storm dissipates. Radar estimates and rain gauge reports indicate rainfall rates greater than 5 inches per hour occur with these thunderstorms, albeit for just a short period of time, often 5 to 10 minutes. Tropical storms and hurricanes produce similar rainfall rates, but on longer time scales. And since these thunderstorms are short-lived, the total rainfall amounts typically do not exceed an inch or two. But since that inch or two falls really quickly, it can overwhelm storm drains and cause minor flooding issues, which often go away as fast as they arrive. This is an interesting event. This is Cummins Falls State Park. Here's Putnam County. Cookeville is right here. And Cummins Falls is right around in this area. This flash flood that occurred was in 2017. It was just a very typical summer thunderstorm event. I see storms moving along pretty good. And then this caused rainfall of about 1 to 2 inches in the upstream portions of the basin in and around Cookeville. And then the downstream portions really didn't see much, maybe 3/4 of an inch. But the peak rainfall rate in that basin was 5 inches per hour. And so the runoff from that quickly overwhelmed the people that were below the falls here swimming and hanging out on the rocks. And you can see in the picture the canyon walls are very steep, so there was really nowhere to go for safety, and many needed to be rescued. Just so happened that the helicopter pilot happened to be nearby and helped save some of those people. And at our office, I remember we had been watching the radar and the storms moving through, and they really got more rain in Cookeville, so we were more concerned about flash flooding in Cookeville. But then we started getting water reports of people needed to be rescued, and so it was a very interesting event. And then since then, measures have been put in place that really keep people out of the park just due to this risk for flash flooding. Tropical systems develop in the Atlantic Ocean when an easterly wave moves off the coast of Africa and taps into the warm, moist air of the tropics here in the Atlantic Ocean. The storm intensifies kind of in these 5 steps here shown. That warm air moves across, evaporates the water, turns it into water vapor, and it rises and condenses, and then keeps rising. That warm air continues to rise with the moist air from the ocean and takes its place, creating more wind, and eventually becomes a tropical storm, which is an organized circulation. But not all tropical waves become tropical storms or hurricanes. Many dissipate just after a few days. In the Pacific Ocean, typhoons are the same as hurricanes, but they form off the coast of Central America. They travel all the way across, striking Southeast Asia and even into parts of Northern Asia and Japan. Largest typhoon recorded was Typhoon Tip, which had a central pressure of 870 millibars. Most of the hurricanes we see reach the low 900 millibar range. Tropical Typhoon Tip had winds of 180 miles per hour and was as wide as the distance from Dallas, Texas to New York City. The biggest threat from a tropical system is the storm surge, followed by the high winds. Fortunately for us in Tennessee, we don't see those. Our biggest threat from these is going to be the heavy rain and any tornadoes associated with the circulation. These tropical systems can bring widespread tornadoes, usually on the weaker scale, often EF0 to EF1. Here's some stats from Hurricane Harvey and its impacts in the Houston area. Over 60 inches of rain measured in the Nederland, Texas area. In Tennessee, Middle Tennessee here for Nashville anyway, our annual average is about 48 inches. 6.5 million people received at least 30 inches of rain over 6 days. There was a rain gauge on Clear Creek, southeast of downtown Houston, that measured over 5 inches of rain in an hour twice over 2 consecutive hours, so 10 inches of rain in 2 hours, and then 15 inches of rain in 4 hours. And another rain gauge nearby recorded over 6 inches of rain in 1 hour. This big picture here shows all the people with boats that came to help rescue people in the Cajun Navy. They were a big help to people like you and flying in the helicopters and wading through the waters here to get people out of harm's way. And then the pictures here on the bottom here, these lists, these are a list of all the water rescue reports that came into this one emergency management department. And this TV here, this is the corner on this wall here. So all these lists stretch from one wall to the other, and even a little bit over onto the third wall here. More recently, the flash flood in Waverly was a very significant event. This graphic here on the bottom right shows the rainfall that caused this devastating flooding that killed 20 people. The area in red indicates at least 6 inches of rain. If you move up to the purple color, that's at least 9 inches of rain. And then here in this little white area, that is the max rainfall amount of 16 to 18 inches, which fell in McEwen. And the rain that developed in the overnight hours really intensified that morning. Had that peak flooding occurred during the night, or even during a weekday instead of a Saturday morning, we feel that loss of life would have been much greater. Statistically speaking, this was a 1 in 1,000 year event, or to put it another way, it has a 0.1% chance of occurring in any given year. That doesn't mean we will go another 1,000 years before another extreme rainfall event occurs, but the odds of it occurring again are very low, at least for this location. A rain gauge operated by TVA in McEwen measured 17 inches of rain in 24 hours. This amount is a new state record. It also recorded peak hourly rates of 3 inches per hour. And it recorded that for 3 hours from 5 a.m. to 8 a.m. So 9 inches of rain fell during that time frame. And it also showed instantaneous rainfall rates were greater than 6 inches per hour. Trace Creek, that flows through Waverly, really begins up here in McEwen and flows down to the Tennessee River, which is about 17 miles away. Elevation change is about 400 feet from McEwen down to the river, so it's a decent slope. But really, the interesting part about Trace Creek is in the town of Waverly, it's only about 1.5 miles wide. And you can see these tributaries that feed into it are very, very short. So that peak rain that was falling accumulated into Trace Creek quickly as water was moving downstream here. So it's really backed up in and around town. And we see similar setup in the Duck River. If this were the Duck River, the tributaries that feed it are very short, so that can lead to rapid accumulations of rainfall runoff into the creeks and river system and cause quick rises. There was no gauge on Trace Creek, but there is one in the area on the Piney River. Before the river started rising, it was about 3 feet, and within 5 hours rose 29 feet to almost a level of 32 feet here. Our action stage at 10 feet and our major flood stage here at 24, it went from action stage to major flood stage in 2 hours. The peak crest exceeded previous record crest by 5 feet. And in the last 50 years, this was only the 4th time the river rose above 20 feet. So it doesn't flood very often there on the Piney River. Some pictures of the devastation in Waverly. Flowing water ripped up asphalt on the roads, which happens, and why we encourage people to not drive through flooded roads, as that road may be gone. Anything not anchored to the ground gets washed away, even some structures that are attached to foundations. You see the mobile homes here shifted. Here's sheds. And then here is just a foundation here on the bottom right with the structure removed from it. And then in this upper left picture, you see a fire. Fires are common during floods, and with no way to get to them, they can burn for several hours. And automobiles are surprisingly buoyant and will often float some distance away from where they were parked, but always nose down due to the weight of the engine being in the front. So to recap, each season brings their own flood risk across Tennessee. Winter rains cause more widespread flooding, river flooding, especially when it rains for several days. In the springtime, flash flooding occurs from passing weather systems, and the risk is higher before vegetation greens up. In the summer months, thunderstorms produce intense but brief downpours, which can overwhelm storm drain systems, and whether they are in rural or urban areas. Passing tropical systems can bring their own challenges, of course, but are more likely to produce significant rainfall rates and amounts. This is the end of this training video, so thanks for watching.